My name is Mike Pizzo, and I'm a senior program manager in the web data group at Microsoft. I've been working on data access technologies within Microsoft for a little over 10 years. So I was involved in the early days of ODBC and worked with the standards committees to get ODBC progressed through as an international and ANSI standard. Following ODBC, I worked on OLEDB and ADO, which together make up Microsoft's Universal Data Access Strategy, and is the interfaces and methods and objects you've come, hopefully, to know and love as how you access data in the native world, in the COM world. I first became involved in the .NET platform a little over 2 years ago, when we had some architectural offsites to start discussing this platform. Of course, it wasn't called .NET at the time, and it has gone through very numerous renames in the process. But the idea was the same. And I started looking at this platform and trying to understand what accessing data meant in this platform. While it was important to make sure that we leveraged existing investments in ADO and OLEDB, and were able to access those stores, we wanted to do more. We wanted to take advantage of some of the new innovations, both of the .NET platform and some industry innovations such as XML. So what we came up with was this integrated ADO Plus architecture, which combines the best of what we have with data access along with XML. And I'm going to talk today a little bit about how you actually use ADO Plus and XML. And we're going to do this by way of building an ASP Plus web application. In the process, we'll go through using data streams. We'll go through using connections and commands. We'll have data sets. We'll even throw a couple web methods in there along with XML. But I want to start off talking a little bit about what data looks like in this web platform for those people who haven't been able to be to the previous presentations on ADO Plus and XML. We'll go into a little detail about some of the different types of data that you may have in your application. One of the things that we've done in this .NET framework is we've defined explicit models for different types of data so that we can optimize for the forward-only case versus the case where your data is cached. We'll then go through and build an application showing different instances of different types of data access and talking about what is appropriate for each of those cases. So what does data look like in the web platform? Well, on the left-hand side, we start off with commands, connections, and data readers. These objects make up what we call the managed provider. The managed provider is similar in nature to the OLEDB provider, except for the fact that the objects it exposes directly are the equivalent of the ADO objects. That is, the connection object exposed by the managed provider looks like an ADO connection object. The command object exposed looks like an ADO command object. The data reader looks like a forward-only, read-only record set. So this is how the managed provider is how you interact with a data store. Typically, when we went out and talked to customers, various .com and financial industries customers, we found out that typically interactions with databases, they didn't keep state in the databases. They didn't have server cursors unless it was to work around a limitation with multiple cursors per connection. Typically, they got data out of the database and then did something with it, and based on what they had, inserted data or made other changes to the database. So we wanted to define an object for working with data in a disconnected manner that was customized and designed from the very beginning as an explicit cache for data. And that's the data set. The data set is an object that knows nothing about connections or commands. It knows nothing about data sources. You can create one of these things out of thin air and create tables and rows and columns in it, push in your data and start using it, and everything works fine. Because it's disconnected, it works well for serialization. You can serialize it as XML. And it's over the data set that the controls, the visual designers, and code gen strong typing, which we'll talk about a little bit later, all work. Now, for the case where you have data in a relational database and you want to push that data into a data set, the managed providers have one more object called the dataset command. The dataset command manages the gosh, it's been a long week. Manages the interaction, that wasn't that tough, between the data reader, the connections and commands, the data source, and the data set. So you talk to the dataset command when you want to push data into a data set or take changes from the data set and propagate those back to the back end. So what you have on the left-hand side is similar to what we have today with OLADB and ADO in the native world. On the right-hand side is our XML story. The first thing you'll see in our XML story is that we have something called an XML reader. The XML reader is a parse-level interface to XML. So in the case where you're simply processing XML, you're reading data and doing something with it and then not keeping it, you're storing it in your own memory or just adding up values, you don't have to cache all of the XML into a DOM before you use it. So the XML reader is a stream interface over XML, much like the data reader is a stream interface over relational data. In the same way the data set is a cache for relational data, we have something called the XML data document, which is a cache for XML data. The XML data document is a W3C compliant object, W3C compliant DOM for storing XML. It's what we like to call the .NET binding for W3C DOM. And over the XML data document is built things like XPath, XSLT for transformations, and validation, along with something that you may have heard Chris Levitt talk about in his presentation earlier today called the XML Navigator. Now, in the native world, we have XML on one side and relational on the other, and never the two shall meet. It's not entirely true. You can save an ADO record set as XML, but it's ADO-specific XML. And you can load back in an ADO record set only from the XML format that it's saved out. We've gone beyond that in this new .NET platform, understanding the importance of XML and at the same time the usefulness of the relational model. And we have the ability to relate the relational data set and XML data document models such that you can look at the same data through either a relational view or an XML view. So this is very useful if you have XML that has a lot of structured data. You can load it into the XML data document, and then you can view it through the controls, the designers, the code gen, and so forth. It's also useful if you have relational data that you want to load into the data set, but then you want to do XML things with it. You want to do transforms or XPath queries or even validation over that. So once your data is into this framework, whether you load it into the XML data document or the data set, you can view it either relationally or as an XML tree. And when you make changes to one view, those are automatically reflected through the other view. Let's talk a little bit about the different types of data that you'll typically have in your ASP Plus or really any application. The first is what I call application data. And this is something that people don't necessarily think of as data. They sometimes think of it as application state or just variables within their program. Application data is data that is generated at runtime, on the fly. It's not gotten from a relational database. It's not even read out of a file. Typically, it's generated in response to user actions. So the user may be, in this case, adding items to a shopping cart, where you're building a local cache of those items. It may also be a log file. It may be something else, but it's generated on the fly. It's not obtained from any database. A second type of data is database data. As I said, about a year and a half ago, we went out and we talked to a number of .com companies and a number of financial industries groups about how they used data and represented data and managed and worked with data, and in particular, what they had in their databases. And what we found was the recurring usage pattern was really one of publish and update. So they had a tremendous amount of data in their database, be that news articles, be that products in an e-commerce website, be that financial information. And what they would do is they would publish from that database the information that was in the database. And the users would access that typically in a read-only fashion. They wouldn't actually go make changes to the stock price, for instance, or update an article. When people did interact with the database, it was generally in terms of an insert into the database. So even when there was an e-commerce site, such as Amazon.com, who had published their books up on the web, the user didn't interact by going and reducing the number of copies of a particular book by one. They executed a stored procedure, or typically inserted a record, an order record, into a database, and then processing on the server took that inserted record and did the decrement of the inventory, did the credit card validation, and sent that off to fulfillment to actually be shipped out. Finally, there's XML data. And again, XML has just really taken over as a de facto standard for moving data around between multiple tiers and multiple businesses and clients. And we'll talk about that a little bit more later as well. The rest of the presentation, I'm going to drill down on the following topics, and that is specific instances of ways that you use data when building your ASP Plus application. The first of these is what I call serial result processing. This is the case where you've executed a query, you've gotten back a stream of results, and you're just processing those in a serial manner, one after another. You're never backing up. You're never rereading a row. You don't need to cache it anywhere. You're just trying to read those records as quickly as possible. An example of this is when you're generating an HTML table. You're just taking the results of that query, formatting it as a HTML string for a row of a table, and then doing a response.write to send that as quickly as possible down to the customer. Another example is where you have a number of rows and you're trying to process those rows, adding up a particular column, doing some calculation on a column. And a final example is binding to a web form. So Susan did a presentation in this room just prior to this one where she talked a lot about data binding. And one of the things that we will support, not in the PDC disks that you have, but in the Beta 1 version, is the ability for controls to bind directly to a data reader. One of the major advantages of using the data reader is that it doesn't have to cache the data. It knows that as soon as you move to the next row, you will never again look at that previous row. And so it doesn't have to store everything in memory. The typical usage scenario for a data reader is to execute a command. Once you've executed the command, and we'll see examples of how this works shortly, you can just process those results directly. The processing of the results looks a lot like the processing of the results of an ADO forward-only record set. One change that we've made is rather than calling the method to move to the next record, move next, we've called it read to emphasize the fact that you are reading a stream of data from the database. Otherwise, conceptually, it's the same as move next. Once you've positioned on a particular row, you can access the value out of that row as you would access a field out of a record in an ADO record set. That is, you can use the bracket notation and pass in the column name that you want to access, and it will return that column as an object, which can then be concatenated with a string, can then be calculated, can then be cast to another object, or whatever else you want to do with it at that point. As I said before, starting with Beta 1, you will be able to pass a data reader directly to a web form control and bind that way, simply by setting that control's data source property to your data reader and then calling data bind on that control. There is one small bug in this PowerPoint. One day we'll get a PowerPoint that we can actually compile, but there should not be the open-close brace after my data reader on that first line. So I'm going to show an example where we actually go out and do a query against a database to obtain a list of categories. The code exists in the PowerPoint presentation, so when you get the disk and bring it home, you can look at the code example there. But I'm actually going to show you the real code, and we'll actually build this. So we're going to start off with this file called categories.txt. And categories.txt is a piece of code that's going to go out and query the database for a list of categories for my e-commerce web store application. And it's going to use the results of that data reader, the results of that query, to populate a drop-down list box. So at the top of this ASPX page, I have import statements to define the namespaces that I'm using. The first is system.data, because within system.data is the data set and related components. The second is system.data.sql, because I'm going to use the SQL Server managed provider to talk directly to SQL Server and get my results. So although I could have done system.data.ado and gone through OLADB and any existing OLADB or ODBC sources, we've written a direct SQL Server managed provider, and that's the one I'm going to use in the code example. The third import statement imports the order processor namespace, and I'll describe what that is towards the end of the presentation. Once I have those defined, everything else is fairly straightforward. For the purposes of demonstration in this example, I've put everything into one ASPX file. So I've used the script tag, and I have the script at the top and the HTML form at the bottom. If I was actually deploying this as an application, I would probably put all of my code in a separate file. So that could be compiled and run and separately maintained and so forth. Note that using ASP+, I can use C# as my language within my script. And in fact, that's what I've done. All of the code examples I'll be showing today are written in the new C#. So the first thing that's going to happen when this page gets loaded is I'm going to call the update categories method. Update categories is the method that goes out to the database and queries for the latest list of categories supported by my web application. The code should look very familiar to any existing ADO programmers. I'm going to start off by creating a connection, and I'm going to pass in the connection string as a constructor argument, because the .NET framework allows me to have constructor arguments in all of my languages. I didn't have to do it this way. I could have done it the old ADO way, where I create a SQL connection, and then I set that SQL connection's connection string property to the string I created before. This is just a shortcut I'm taking in the .NET framework. Once I have that connection with the connection string specified, I call open, just like I do in ADODB. And now I'm going to create a command. Again, I can create the command by newing a command, setting its command text to the SQL query, and setting its active connection property to the SQL connection object that I previously created. But instead, I'm going to again take advantage of constructor overloading to pass in the select statement as well as the connection that I want this command to use. Now in the PDC disk, when you execute a command, it returns a SQL data reader as an output parameter. So in this code example, I first have to define my SQL data reader, and then I call execute, passing in the output parameter SQL data reader. In the beta 1 release, we will be changing this so that in fact execute returns a data reader, much like execute in ADODB today returns a record set. Also, as I said before, in the PDC time frame, we can't yet bind directly to a data reader. We will have this functionality in beta 1, but in the meantime, in order to bind, I need to put the results in an array list, because the bound controls know how to bind to an array list. So I'm simply going to create an array list called categories, and then I'm going to loop through calling read, and each time through, for each record that I come to, I'm going to call getString0 and add that value to my array list. Now notice here, I did something a little different in how I looked up the field. As I showed in the previous example, I could have looked it up by name the same way that you'd look up a column in a record set. However, that returns an object. It looks it up by string and returns an object, which is less performant. When we first designed ODBC, we did something that was pretty radical in the industry, which was define an architecture whereby you could connect to a database that you didn't know at the time the application was written. You could execute a command given to you by the user that you knew nothing about when you wrote your application. You could bring back results that you didn't know the shape of and discover the shape and do interesting things with that result, bind those results. So it was a very ad hoc model. When we did OLADB and ADO and the follow-ons, we built upon that ad hoc model, and that's a good model. It's important to be able to do that. But in the past, we have sacrificed the common case where you know the database that you're going against, you know the commands that are being executed or the stored procedures, and you know the shape of the results. In those cases, you're paying overhead in order to describe the results, in order to look up at a runtime fashion what you're trying to get and return the value as a variant or an object. So what we allow you to do with the data reader is we allow you to call type-specific accessors, getString to return a string column, getInt32 to return an int32 column, getBool to return a Boolean column, and so forth, and specify the index of the column that you want to access. This is going to be the most performant way to return values, because you don't have to create objects, and you don't have to look up the values when you retrieve them. So I'm going to go through and build up my array list, and then I simply bind my category list object by setting the data source property to that array list, and then calling data bind. The final thing I need to remember to do is close my connection, because I don't want to leave that open. I don't want to tie up those resources. So that's what the code is going to look like to go out, get the database, build the array list, and bind it. What does my HTML look like? My HTML is actually pretty straightforward. I've got the standard header stuff, and then I've got this keyword run at server, which means that the controls are going to be processed on the server. Then I simply create a drop-down list ASP control, and I set its ID to category list, where category list, remember, is what I bound to up above. And then with the run at server keyword, that's all I need. Now when I go do my query, it'll populate that control, and then I can select from that, and it'll automatically do that. So let's go ahead and try this out. I'm going to copy this code. I'm going to create a new file called webstore.aspx in probably the most popular development environment that we have at the moment, being Notepad. And I'm going to paste that code in. I'm going to save that off. And as soon as IE comes up, I'm going to try accessing that. So that's going to go out. ASP Plus, since I've never used this file before, is first going to compile it, build it, and compile it, and then it's going to return to me that sample. So there I have my select category, and I have a drop-down list box with the values populated from the database. Okay, you're a tough crowd to please. That's not that exciting, but it's a start. So what I've done here is I've gone out. No, it's too late. Just forget it now. What I've done is I've gone out and I queried a database, got back some results, and populated a drop-down with very little code, very little HTML. But you're right, that's not all that exciting. It's actually kind of fun to play with, but it's not gonna make you succeed or go IPO. So let's go back to the code example and see if we can make this a little more interesting. The next interesting type of data to think about when you're designing your ASP Plus application is frequently used results. Those are sets of results that you'll typically create over and over again. And rather than having to create them each time, you want to be able to create them once and then reference them again and again. ASP Plus provides two types of caching. The first type of caching is page caching. That's where exactly the page you see gets returned over and over again. So perhaps the first page, the introductory page, your home page for your website might be page cached, because everybody hits that the first time they come in, and you want that to come back very quickly. The second, and I think more interesting type of cache, is the object cache within ASP Plus. The object cache lets me cache individual objects that I would use over and over again to save having to create them each time. When you're trying to think of what should go in a cache or what shouldn't go in a cache, there's a couple things to consider. The first is the data fairly static? If the data is constantly changing, like stock ticker quotes, it's probably not something you want to cache. Unless the stock's going down, and then you might prefer to see it that way. The second is this data commonly used? So I probably wouldn't want to put in an application cache one person's request for their stock information, because they're the only ones who are going to access it. Third, is it reasonably sized? You probably don't want to put the entire Amazon.com catalog in the ASP Plus cache. It's just too big. So you want to find things that are common, reusable sets of information that are fairly static, and then you can put them into the ASP Plus cache. The simple interface to the ASP Plus cache looks just like any other dictionary. The typical usage pattern is first to see if the object that you're looking for is in the cache, and if it's not there, to put it there. When you want to cache data in the .NET platform, the ideal object to use for caching that data is a data set. The data set is designed, remember, as a disconnected object. It has no knowledge of connections. It has no knowledge of state. All it knows is its own internal data. What's more is the data set knows how to serialize itself as XML and deserialize itself back into a data set. And these attributes make it an ideal object for caching. So in this example, this simple code example, I have a data set. So I define my data set as a data set. I first check the cache to see if my data, the lookup string my data, already exists. If it does, then I'm going to set my data set to that value. If it doesn't, then I'm going to go through and call some other method to generate a data set, and I'm going to take the results of that and put it into the cache for next time I visit it. So it's that simple to use the object cache in ASP+. The object cache, however, has additional functionality. There are more complex interfaces and methods that you can use in order to specify things like timeout, things that will invalidate the cache, such as a file changing. So you can do a lot more sophisticated stuff than this. But this is sort of the simple, easy way to use the cache. Now we're going to have an example where we actually go through and, given the category that has been selected, we go off and we query all of the products that match that category. Since that query is going to be a fairly common query, since my products within a category don't change frequently, and since a lot of people are going to ask it over and over again, and it's a reasonably sized result set, it makes it an ideal candidate for putting in a cache. So that's what we're going to do. So here's the code I'm going to use to go query the data and get the information to put in the cache. I'm going to start off by getting the category name out of the drop-down list that I created in the previous example. Once I have that, I'm going to execute code very similar to what we just saw. I'm going to look inside and see if I already have that product in the cache. If I do, I am simply going to go down and get the data set out of the cache and bind to it. If I don't already have that in the cache, I'm going to go through an example very similar to the previous one where I create a connection. Now this time, since I know the destination for my results is going to be a data set, rather than creating a command and getting a data reader, I'm going to take a shortcut and use the dataset command to put the results directly into my data set. The way I'm going to do that again is using constructor overloading to pass in the command that I want the data set to use in order to populate the data set. Now, in a real production environment, I would probably be calling a stored procedure here and passing a parameter. But for simplicity in giving the demo, I'm going to go ahead and specify a query with a subselect that actually concatenates on the category name. And again, I'm going to pass in, as a second argument to the constructor, the SQL connection that I want the data set command to use. Now I'm going to create a new data set, and I'm going to call fill data set on that data set command, passing in the data set, the destination for the results, as well as the name of the table that I want the data set command to use to place those results in the data set. Now, I've not actually created that table in the data set yet. I just knew the data set. The data set command is going to see that that table doesn't already exist. It's going to create that table and put the results of the query into that table. Once that happens, I'm going to go ahead and bind to the results by setting the data source to the 0th column, which will be the products table, using the default view property of that table. Now, I also could have, if I wanted my code to be more robust and safer, I could have passed into the tables the string quote, products quote, to make sure it found the right table. But since I knew there was only going to be one table in there, I can pass in just 0. So that's my code for actually going out, getting a data set, creating one if it doesn't exist, and populating it with the products for the selected category. Let's look at what the HTML looks like. The HTML is, again, very straightforward. I've got a button whose onClick method is the method we just saw, this category list underscore select method. So when I click on the button, it's going to run that, and the last step in that is to bind to a control. That control is what I describe here as the ASP data list control. Data list is a control built into ASP Plus that is on your disks and knows how to bind to a number of different objects. The idea is product listing, which is what I bound to up above. The key field is product ID, which allows me to get the selected value out of there. And then I'm simply going to create a template that binds to both the image as well as the product name and unit price. So let's paste this into our application and see what happens. We'll save that off. And we'll refresh. So again, since I've added new code, ASP Plus is going to go recompile, reload that ASPX page, and now I have not just my drop-down, but I have a select button. And when I click on the select button, it's going to go out, query for those values, and bind them to that ASP data list control that I created. Thanks. Now, once it's queried that, it's now in my cache. So if I select the same product again, it's going to come back very quickly. It's not going to go hit the database for the product again. It's only when I select a new category that it's going to go out and query that. Okay, so my application's starting to be a little more interesting. I've gone out and I've queried dynamically for the set of categories and populated a list box with those values. And I've added a button where when someone selects a category, I can go off and get all the products for that particular category. But we're not done. Hold your applause. We're still not to IPO. The next type of data we've already talked about a little bit, and that's application data. The application data, again, is data generated at runtime, which may be application state, is typically generated on behalf of the user following user actions. Again, an ideal place to store application data is the data set. The data set has all the things that you want in order to keep track of data, to move data throughout the different tiers of your application, or even just as a convenient place to store information. So in this case, when you're building an ASP Plus application, you need to take that data and put it someplace so that the next time the user comes back to your website, they'll find it again. And the typical place for putting that is session state. Now again, a data set is a perfect candidate for storing in session state because it is fundamentally disconnected, so you don't have to worry about it holding on to any connections or any other resources, and because it's serializable. It knows how to read and write itself as XML. The mechanism by which I can put a data set in session state is much like how I put the previous data set into the cache. And that's, again, using the dictionary APIs. And the usage pattern is to see if it already exists. If so, use it. If not, create it and put it in that session state for the next time around. So let's see how we can implement a data set to represent our shopping cart. Here the code's going to get a little bit more complex, but not a whole lot. And the complexity is really just in managing the semantics of the shopping cart. All of the storage and managing of the data is pretty automatic. So again, what I'm going to do is when the user calls update shopping cart, I'm going to go and see if I have a shopping cart already in my session state. If so, I'm going to bind to it down below. But if not, I'm going to create a data set to hold that shopping cart. I'm going to add a table to that data set called shopping cart, and then I'm going to add columns to that data set, or to that table. The first column that I add to the table is going to be a primary key called product ID, and it's going to be an int32 column. Then I'm going to add quantity, name, and price columns, and finally a total column, where the total column is a computed column that multiplies price times quantity. Once I have that table defined, I'm going to add it to my shopping cart. Or, I'm sorry, I'm going to add it to my session state, calling it shopping cart. So the next time I go into session state, it'll be there. Again, I then bind by setting the data source to be the default view of that shopping cart, and then I call data bind. I've got a couple other methods here. The first is product listing select. What this method is going to do is it's actually going to be the method that adds the item to my shopping cart. Now, I could just add it based on the information that I already have that I put in the cache, but that wouldn't give me a chance to demonstrate singleton selects. So what I'm actually going to do is when the user clicks on the product to add it to the shopping cart, I'm going to go again, query the database, and bring back a single record, which is the information for that product. And that may be information that I didn't bring down the first time because it wasn't necessarily information that I needed just to display the individual products. It also is the very most current information so that if the price has changed or something else has changed since I enumerated the products, it's going to go out and get the latest information for that product. My customers are used to, when they have shopping carts, if they add the same item more than once, rather than have that appear as two different line items, just have a quantity column that gets incremented to 2 and 3 and so forth. So I'm going to do that in my application. And the way I'm going to do that is I'm first going to check to see if the product that they've selected already exists in the table. And the way I do that is call find on the shopping cart table and pass in the product ID that I'm looking for. If that finds the value, it will return that as a data row, and then I can simply increment the quantity by 1. If it doesn't find it, I'm going to drop down to my catch routine, and it's going to go through, and again, code that at this point should be very familiar. You can write it as well as I can. Create a connection, open it, create a command, execute it, get back a data reader, position on the first record, and then I'm going to go through, create a new row in my table, and add the data to that row. And I'm going to do that by calling new row. I'm going to set the product ID to the product ID I was querying. Quantity to 1, since it's a new item, I know that there are no previous instances of it. The name, I'm going to set using the product name field from the data reader. The price, I'm going to set using the unit price field from the data reader. And then I'm going to add that row to my shopping cart. Again, I'm going to close the connection, and then I'm going to go through and update the shopping cart. Then I have one other little helper function here just to allow the user to clear the cart. And all that's going to do is get the shopping cart as a data table out of session state, call the clear method, which clears the data but not the schema, and then call update shopping cart, which will rebind and show that there are now no values. The HTML, again, is extremely simple. All I'm doing to display this shopping cart is binding to it using the data grid control, also supplied as ASP, part of ASP+. Now, the grid control has a lot of fancy bells and whistles, and you can tune it to bold and italic and shadow and hide or show columns and do all sorts of other stuff. But I'm not going to do that. All I'm going to do is just simply use the default form of the data grid. And again, the ID is shopping cart data, and that's what I bind to in my update shopping cart code. So let's go ahead and add this to my ever-growing e-commerce application. First I'll add the HTML. And the code. I'm going to do one more thing, which is I'm going to make sure that I initialize the shopping cart. Save that. I'm actually going to try to trick. Oops. What's going on here? Okay. So now I'm going to go off and hit that website again. Again, it's going to compile that. It's going to, again, since it's a new session, go out and requery the database for my categories. Once I have the categories, again, I can select. Now at the bottom, I have my shopping cart, which is currently empty. But if I click on an item, it'll add it to my shopping cart. Tough crowd. All right, so now I've got the ability to go out, dynamically query the products, the categories that are available, get the products, stick those in a cache, and now add those to a shopping cart, where the shopping cart is simply a data set that is kept in my session state. but we haven't been able to order anything yet. I'll talk briefly about singleton query. What we did just a minute ago when we went out and we executed the query and brought back information for a single result, for a single product, was called a singleton query. One of the things that we wanted to make sure worked very well in this architecture was the ability to return a single result. So you didn't have to process through a lot of results. You didn't have to build a lot of extra infrastructure, if you're just getting a single result back. The mechanism for doing singleton queries are basically to execute a command and retrieve results from a data record. A data record is equivalent to a row in a record set, and every data reader extends data record, which means that every data reader is a data record. And so you can access the columns on a data reader directly as if you were accessing columns on a data record. Again, as we saw, you can use ADO-like accessors for convenience. This helps make sure existing code is more easily portable simply by looking up the name according to a string and getting back an object. But for best performance, you want to use type-specific accessors where you get string to return a string column or get double to return a numeric column. And you want to specify by ordinal the column that you're getting back as opposed to forcing it to go and look up the name according to a string each time. This code example is the one that we just saw, which goes out and gets the product details by querying a particular detail. So we won't go through that again. Next, I want to talk a little bit about web methods. Web methods are a very exciting new mechanism that's fully supported by ASP+. It's a way that I can go to some website, use some functionality on that website, pass it in arguments, and get results back from it that aren't human-readable HTML results. So I can use some processing on a website, such as credit card validation, or some other type of processing where I'm not getting back HTML. I can do my own thing with the results. Something you commonly want to do with a web service is pass data. And we've already said that the convenient form for working with data is a data set. The data set, again, is fundamentally disconnected, which makes it ideal for remoting between different tiers or even from one application to another or one server to another. In fact, web methods know how to serialize to and from XML, how to take a data set, write it out as an XML in a SOAP payload, and rematerialize that on the server. So I can use, as the example here shows, I can define a method that takes a data set as an input argument and returns a double value or even returns another data set. And then I can do processing using that argument as a data set. I don't have to write it to XML, reparse the XML, refigure out what to do with it. I can simply pass it as a data set, and ASP Plus will take care of all of the serialization, remoting, deserializing, and so forth. So in this example, all I'm doing is going through the orders table, totaling up the amounts. So let's see what it looks like to call a web method from our growing e-commerce application, which is almost ready to go IPO. Okay. My code here is actually fairly simple. What I'm going to do is when the user clicks the Place Order button, I'm going to get the shopping cart out of my session state. I'm going to create a new instance of Order Processor. Order Processor is an object that contains the submit order method that I'm going to use to pass off my data set. And the way I will have created this is I will have created an ASMX file, which is a web method file in ASP+. And based on that, I can hit that URL, generate a proxy for calling that, and then that proxy just gets loaded into my application. I've already done that. And so all I need to do is create a new instance of the order processor web object called the submit order web method, passing in the data set for my shopping cart. So again, I'm passing a shopping cart directly across. That's going to return me an order amount. If it's less than 0, it means that there was something wrong with the order. Either the credit card validation failed or there's some other problem with the order. So I'm going to print out an invalid order as the response. If everything works, I'm just going to set up a tag that says order amount equals and prints out the total of the order amount. Then I'm going to call clear shopping cart and then update in order to update that shopping cart. The HTML is still extremely simple for what I'm doing. All I'm doing here is adding a button that on the click event calls the place order click method directly above, and then adding a message that I can pump the result into once the web method returns. So let's add this. I'm going to go through and refresh. Oops. Before I do that, let me clear my cart. It doesn't matter. It's going to go repost anyway. Clear my cart. There we go. So now I can go out and select an item, add it to my shopping cart. When I add a second one, it increments the count. And now I can click on checkout. What checkout's going to do is it's going to go call this web method, which is going to do a number of different things to process the results and return to me the amount, which is done right here, and the total amount was $778. Thank you. All right. So we're ready to go to IPO. But what really happened there? There's a little bit of magic, and I said web method and waved my hands, and magic happened, and we got back a result. Well, what typically happens when this web method, this service, gets this request for this order? It has to process this order. Well, in the business world today, we're seeing an increasing amount of XML. XML is the lingua franca of the web for moving data around. And XML is convenient for a number of reasons. One is that you can exchange data in an interoperable format between different businesses, a la BizTalk. One of the powerful things there is that you've got a standard representation and a form that you can use transforms and validations against. Again, using BizTalk tools to create transformations and create validation schemas in order to process and validate that data. The data that we passed to this web method was a data set. Now, in this case, the web method was written as an ASMX file, so I actually got back the data as a data set. And if I returned a data set from that, it would have been returned to my application as a data set. However, if my application wasn't an ASPX file, if it was just the browser that called this method and that method returned a data set, what I'd get back is XML. Because XML is the native serialization format for a data set. But if I want to work on that data in the data set as XML, then I need some way to view that relational data as XML. And that's what we do with the XML data document that I talked about at the beginning of the presentation. So I'm going to go back to our code here. And I happen to have a pointer to the code for that order processor ASMX. This is what ran on the server when we passed it our data set. So let's take a look at what it looks like. It starts off by specifying the namespace as system data, system.web.services, which is what I use in order to do a web method or web service, system.newXML, which is where all the XML functionality is located, system.newXML.xsl, because I'm going to do an XSL transform, And finally, system.data.sql, because again, I'm going to interact with the SQL Server database. Once I've specified those using arguments, then I define my class order processor. And the first thing I have in order processor is a method called submitOrder. Simply by putting this annotation web method before the method, when I save this out as an ASMX file and hit it with ASP+, ASP+ knows how to compile this and how to expose submitOrder as a method. SubmitOrder takes a data set and returns a numeric value, which is convenient because that was the signature of the function that I called from my web store application. It's going to go through, and actually the first thing it's going to do is it's going to take advantage of the fact that what it got back was a relational data set, as opposed to just raw XML. And what it's going to do is it's going to take that data set that was my shopping cart, and it's going to modify the structure of that. It's actually going to go in and add a column to my existing table, and then insert the current time into that, so that for tracking purposes, I'll know exactly when this particular order item was placed. So it's going to go through and add that column and then cycle through the rows, setting the order date value for each of those rows to the current time. And at the same time it's looping through, it's just going to keep a running total of how much I paid in this in order to send that back at the end of the processing. The next step is going to be to apply an XSL transform. And it's going to do that by calling my processOrder method. Let's take a look and see what processOrder looks like. ProcessOrder uses an XSLT transform in order to process via an XML transform my order, in order to convert it into the proper format, either for myself or for my business partner that I'm going to hand this off to. So the first thing I need to do is get my data set into an XML format. And the way that I do that is by defining an XML data document and passing my data set into the constructor of that XML data document. Simply by doing that, I now have two views of my data, the XML view and the data set view, the relational view and the XML view. Given that XML data document now, I can create a data document navigator which lets me very efficiently walk over the XML representation of my data set data without creating extra objects and nodes as a W3C DOM would be forced to do. Once I do that, I'm going to create a new instance of a transform and load that transform with a particular style sheet. Finally, I'm going to call transform, passing in my navigator. There are various forms of transform. I can either get out an XML reader, as I'm doing here, or I could have written it directly to an XML writer. So I'm going to call transform, and I'm going to get back an XML reader that I'm going to return to the method that called me. The next thing I'm going to do is I'm going to set up validation. We have parse time validation in the bits today, and we're looking at doing runtime validation. But parse time validation basically is a way that you can set up on the parser validation such that as you read that file, it will verify that all the nodes coming across are valid. And if at any time it encounters something that's not valid, it can call your callback handler and give you information about what was wrong. So the way I'm going to set that up is I'm going to specify that my validation on my data reader is via a schema. And then I'm going to specify that the callback to call, if anything goes wrong, is my validation callback, which can receive the error ID and other information, which I'm going to strictly ignore and simply set the flag to false if it's not valid. So now I have set up on an XML data reader validation over the transformed information. So the final thing I'm going to do is actually do some processing to place that order. And actually what I'm going to do is simply log that order into the database. And assuming it's valid, the order will get written in the database, and I'll be able to return that value to the caller. So the way I'm going to do that is through place order. I'm going to create a new XML document and load it with the data reader. Now calling load is going to load that data into the document by reading through the reader, and if anything invalid is encountered, it's going to call my callback routine, which is going to say, no, this wasn't a valid order, and it's all going to get kicked out. Then one more time, just for good measure, I'm going to create a connection, open it, create a command, give it my connection. This is going to be a parameterized command where the XML that I'm inserting into the database is a parameter, which is the XML that I loaded from the XML document. Then I'm going to execute that command, which is going to insert the XML into the table, and then I'm going to close my connection. So that's exactly the code that gets run each time I add stuff to my shopping cart and click checkout. And if you go and look at the database, this is all running on my local machine, which is why it's a little slow. And look at the rows. Come on, Susan. There are the orders that I've placed as XML in my table. So the final thing we showed there was, in fact, a database transaction, where we interacted with the database and we inserted an order into it. In this case, all we were doing is inserting an order, so we didn't need to begin it in a transaction, because it was a single activity. If I wanted to be safe, I would have had try-catch, so if the insert failed, I could catch that and return some error to the user. On that connection on which I executed the command, I also have the ability to specify transactions. This is important if you're doing things like debit and credit. If you're doing a debit credit where you're moving information from one account to another by debiting the first account and crediting the second, you want to make sure either both of those succeed or they both fail. Because your customers get a little irked when you reduce money from their account without crediting some other equivalent amount. So the way I would do that is on my connection, I would first call begin transaction, which is a method on the connection object, just like in ADO today. I could then call as many commands as I wanted on that connection, and once I got to the state that I wanted, I would call commit, or if I decided not to do the transaction, call rollback. Final note, you want to use stored procedures wherever possible. Stored procedures provide a couple of things for you. It's a nice abstraction of your application and business logic from the actual code within this database for representing what you're doing. It also allows the database to optimize what you're doing, and it gives you a convenient way that you can call a method without creating a big, long, complicated string embedded within your application. And this is the example that we just saw for writing to a database. So in summary, Microsoft provides a comprehensive and well-integrated set of components for the various types of data access needs that you have within the .NET framework. These database components are tightly integrated with the .NET framework and ASP Plus in particular. You've got database commands for doing transactions and data readers for very, very efficient forward-only stream processing of results. You've got the data set, which is a convenient application object for using and managing data, for moving it between the tiers, for saving it off in application state, or just for creating data within the application. The ASP Plus, cache, and session APIs give you ways that you can keep state around for user state. Application state lets you keep common state around across the application. And the cache lets you keep commonly used, appropriately sized, fixed sets of data. And finally, XML gives you a very flexible, interoperable way that you can apply transforms and validation, that you can do business-to-business interchange, and that you can have great client reach. There's not a whole lot of purpose for this slide, given that this is the last presentation of the last day of PDC, and by the way, congratulations for making it here. But on the CDs, you will have a copy of all of the presentations from the PDC, so you might want to take these down as things to look up later to get more information, in particular about ADO+, XML, and some of the things that we're doing with SQL Server and XML. And with that, I'll take about 5 minutes of questions if anybody has any. Thanks.
It's not exactly a question, but the company I work for has been building server-side transactional web applications using your virtual machine in Java and so on for a couple of years now. And there are 8 of us here, and we're pretty blown away by what you rolled out this week.
Oh, blown away in a good way?
Yeah.
Okay, good. Thank you. Yeah, over here.
Somebody mentioned to me last night, I just want to verify this, that if I was actually taking a data set and binding it to a control out on ASP+, and the user was doing bulk edits, say on a grid, that is there some kind of hidden key that I can come back in? Because I haven't heard this discussed at all, the fact that I'm dumping data out in a grid, users editing grid, data comes back, now I got to figure out what state the stuff is in so I can do batch update back against the database, and I haven't seen an example of that at all.
Okay. Let me describe what happens in the dataset update case. Again, all of the logic for interacting with the data source is encapsulated in the dataset command object. So the dataset knows nothing about where you're sending the data to. So the way updates work in the dataset is very similar to the way updates work in a client-side record set today. So to describe how that works first, in a client cursor ADO record set today, when you populate that cursor, the client-side record set tries to get as much information about the data in it as possible. It tries to figure out the tables, the keys, and so forth. Based on that information, it will generate insert, update, and delete statements, which when you call update on the record set, will go back and fire those statements for each row that's changed. The row set keeps old and new values, so it knows how to do optimistic concurrency to the back end. The only problem with that model is it's a closed model. The code that creates those statements and generates them and executes them is all hidden, and you have no way to change those. That's particularly a problem because when we went out and talked to customers, we found out that in most cases, their customers don't update data by doing selects and inserts and updates and deletes against base tables. Most often, things are done through stored procedures, and there's no way in the ADO model today to plug in your stored procedures. So what happens with the dataset command is you create a dataset command and you give it a select statement, and it's going to try to derive insert and update delete statements for that select, much like the ADO record set does. Now you can go in a separate room and work on your data set and save it and load it and do whatever else you want. You can come back and use your dataset command, either the same one or recreate and reconnect a dataset command. And you call update on the dataset command, and you pass it the dataset that you want it to use to get the changes. The dataset command is going to look to the dataset and find all the rows that have changed. The dataset command, or the dataset, like the record set, has the ability to show old and new values and enumerate exactly what rows have changed. So the dataset command is going to then go in and for every new row call the insert statement, every changed row call the update statement, and every delete row call the delete statement. Now, as I said, those are generated by default based on the metadata, and in probably 75% of the cases work fine. But what we've exposed in ADO Plus that we didn't expose previously in ADO is the ability for you to override those insert, update, and delete commands. So you can provide your own statements that use stored procedures or whatever else you need in order to propagate the individual changed, updated, or deleted rows back to the database. There are parameters, and you can associate the parameters with a particular column within the table in the data set, and that's how you sync up the old and new values. And you can decide how much optimistic concurrency you want to use, whether you want to go with all of the values with some row versioning column, or simply to base it based on a primary key.
And I'm assuming it can also change some structure within it once I've got the data set, since it's not bound to a connection as well, unlike ADO.
So yes, you can change structure of the data set as well, structure of the table. You can add things like I did in this example. When you go to call update, you need to make sure that there's a mapping between your current tables and the tables on the database. And the dataset command has a mappings collection that allows you to do just that, to do the appropriate mapping. So the first thing that we did is we provided the same basic functionality as the record set has today, But the most important thing to us in defining this whole architecture is to make sure that we were exposing the right plumbing, the right hooks and mechanisms where you could plug in your own logic. And that's what we've allowed you to do with that updating. So, thank you. That was an excellent question. What's that? Previous slide. Over here.
Yeah, this is in regards to caching objects in the application object. At one time, if you put an object in the application level, it would break the threading. In other words, it would become single-threaded. Is that still an issue?
The .NET framework has a very different model for threading. In general, the idea is that you write your code with no thread affinity, but also no thread protection. Your objects should, for instance, the data set is multi-reader. Multiple people can read it. But it is up to the user of the data set to do any protection in the case of multiple writers. So we haven't done anything in particular. We don't take locks. We don't protect state. We don't put in every single getter or setter, is somebody already in here? Do I have to take a critical section? And so forth. I believe that there are generic, and Brian Harry would be the person to ask about this, generic mechanisms within the .NET framework which allow you to specify the synchronization on a particular object that you're calling. Having said that, putting a data set or something into the session state should not change the fundamental aspects of that data set. So I should be able to interoperate with it the same way as if I hadn't put it in the data set. Now, there were some other problems previously with putting, for instance, record sets in the session state.
Yeah, that's what I'm specifically...
The problem with that was that the record set, depending on whether it was connected to a database or was a client cursor record set, may be holding state. It may be holding connections to your database, and by putting it in your session state, it's holding that connection open. And it's causing other problems in that manner. The fact that the data set itself is explicitly a disconnected object and has no knowledge of any state, has no knowledge of any connections or any particular backend, means that it is very well suited for putting in session state or in your cache. So, again, that was a great question.
Thanks.
There's one over here.
Similar question. I'm confused on what the difference between using the object data caches and using like a session variable.
Okay, the question is what's the difference between the session cache and the cache?
Is the
cache
per session?
No, the cache is application wide. Okay. There's no guarantee that the object stays in the cache. So ASP Plus will purge the object from the cache if you get short on resources or if some other aging rule, the timeout occurs or some other trigger occurs in order to pop that thing out of the cache. So every time you access that, you want to have the code that says, if it already exists, use it. If it doesn't already exist, put it in there. So the cache really is more of an invisible, no guarantee, just someplace to put stuff to optimize access to it, whereas session state has to keep that associated with the user and return it to the user each time they access it.
Thank you.
Next question.
What do I need to install on my Windows 2000 server at a minimum for it to successfully serve up ASP Plus applications?
Okay. You need to install Windows 2000 or Windows NT and IIS. Once you have those installed, when you run the setup that's on your PDC CD, it will install the correct ASP Plus, ISAPI, DLLs, and so forth. Put everything in state. So literally all I did, I ran this whole demo off my laptop, and I had been running Windows 2000 for months. And all I did is I ran the setup for the SDK, and then everything just worked. I was actually amazed.
So there are two CDs. There's the COM Plus Upgrade CD, which you have to install first. And then you have the SDK.
Right.
CD.
And right. What I installed was the SDK.
Okay, great.
And
Thanks.
that should have everything in it.
Hi. Based on what you just said about the cache expiring stuff, in the code examples, why isn't there a race when you're doing your if it's already in the cache, then assign it to something?
And the question is, isn't there a race if I check to see if it's there and if not, put it there? In fact, there is a race condition. It's possible that at the same point that I'm putting something in the cache, another instance of my code is running and is also going to put something in the cache. But it doesn't make a difference for my particular application because what I'd be putting in the cache is the same thing in either case.
I wasn't talking about that race. I was talking about the race of the cache expiring it when
I
you
see.
do the assignment.
When I access it. That's an excellent question. I think I should have written my code slightly differently to be completely safe, which is get back the object when I check to see if it's there.
Okay, so
And then use it because then I'll have a reference to it. Okay. So you're right. There's probably a little bit of unsafe code in my example. Yeah.
Hey, how you doing? I've been really impressed with what I've heard this week, the power of ASP, the ability to embed more functionality has been there in the past. I grew up as a COBOL coder, so I was actually quite surprised. I'm coming to this as an architect. One of my concerns is that the ability to now embed so much power into ASP Plus might allow us to break down the physical breakdown between the logical three tiers. Get to see a lot of business functionality embedded into the presentation tier. What kind of controls are there or could there be within either ASP Plus or other configurations of the .NET framework to ensure that we don't end up putting all our eggs in the same basket?
So the question, as I understand it, is one of where you place your business logic.
Yeah.
Note that in the example that I gave, my business logic was actually running on my server, on my IS machine. So it wasn't in the presentation layer. And in fact, I had additional validation that went on when I passed it off on the web method that I called.
Agreed. It's more of a general question, having seen what the technology is capable of through the week, not just based on your presentation.
So in general, the philosophy seems to be that you want to report to the user as soon as possible when they've done something wrong. That just saves round trips. It saves, if you can do it right as they enter the information rather than letting them enter 6 pages of information, fire off, and then come back and say, you did something wrong way back there. It's a better user experience. But I don't think that takes the place of validation on the server. I think that's a way to augment the validation so that you get more immediate response. But simply because I had some control that could validate a page on the form that said, this has to be at least a 6-digit code, doesn't mean that I wouldn't have, for instance, database constraints on that column that says this must be a 6-digit value. So I don't know if that answers your question or not.
To a certain extent.
Okay. I'll take one more question.
Hi. We are developing financial applications, and what we really require is a transactional cache.
Mm-hmm.
Is there anything in the .NET framework that will help us with that problem?
So one of the things that we had started to do was something called in-memory database. An in-memory database was a complete transactional cache, multi-reader, multi-writer. We took protection, we took locks, we took latches, we did all of that. When we went out and talked to customers, we found that in most cases, that wasn't what they were looking for, what they were needing. In most cases, it was more of a publish-subscribe model or a single writer model. Or all of the access to that store was done through a common component. So even though multiple customers, clients, might be requesting changes to the same cache, it was all being done through one agent. So it could serialize the changes to the data set. The data set itself wasn't designed to be a fully transactional, robust cache. For that, we have SQL Server. We have a relational engine. And when we talked to the .coms and the financial industry people about a year and a half ago, we found out that in many cases, people were using SQL Server as that interim cache. I would be very interested in talking to you afterwards about your specific scenario and what requirements you have. We realized that we don't go 100% there, that there are some other things you might want to do, and I'd be interested in finding out exactly what it is in your case. So if there aren't any other questions, thank you very much, and thanks for coming to the PDC.